In this slide, we'll be looking at the ASCII. So before I move into explaining what are ASCII, you should all know that machines do not actually understand text. For example, if I write a string which is A, so computer will not understand that I actually wrote an A at the beginning. What the computer will do, it will convert this A into its corresponding binary form. Binary meaning A will be converted into a sequence of zeros and ones. So after A is converted into its corresponding binary form, then the computer understands from this binary form that this represents the character A. So even if you write the number 1 in a string, computer still won't understand this as 1. It will again convert this to its binary, then the computer will understand that this is actually an 1. So to convert a string into binary, at first we need to convert the strings into the numbers. So in the process of converting a string into its binary form, there is a middle process where the string is converted to its corresponding number first. Then the number is later converted into its binary form. So what is ASCII value? ASCII is a short form for American Standard Code for Information Interchange, and it is a code for representing English characters as numbers assigned from 0 to 127. So like I said, before converting a string to its corresponding binary form, there is a middle process, and the character A is converted to a number first, and this number is the ASCII number. So in the series of English characters, each English character has a corresponding decimal value from 0 to 127. We will be looking at two important functions. One of them is ORD, another one is CHR. We will be using these two functions to convert from a given ASCII value to its corresponding character, also to get the ASCII value from a given character. So let's look at some examples. The first one I mentioned is the ORD function. So in the ORD function, in the function argument, I pass a single charactered string. So in this line, in the ORD function, I have passed small letter a as an argument. Please notice I have used here quotation marks. So after I have passed small letter a into this function, in return, this ORD function will give me the ASCII value of small letter a, meaning the corresponding number value of small letter a. Like I previously said, every English character has a corresponding decimal value or a ASCII value. Similarly, if I want to know the ASCII value of the character small letter b, I pass it on into the ORD function as an argument, and in return I get the value of 98, meaning 98 is the decimal value or ASCII value of the character small letter b. So please remember, the ASCII values of small letter a and the capital letter A are not the same, since both of these are two different characters and two different strings. So using the ORD function, if I have a character in hand, I can get the corresponding ASCII values. Let's look at the CHR function. In the CHR function, in the function argument, I pass on a number value ranging from 0 to 127. In this case, I have passed on 97 as an argument. So what the CHR function will do is, it will take in the decimal value or the ASCII value of 97. So in return, give me the character associated with the value of 97. So in the previous example, we saw the ASCII value of small letter a was 97, and in this example, I am seeing it in reverse. I am passing on 97 and I am getting character a in return. So the CHR function returns the corresponding string of a number. So this was the ASCII table, which contains the ASCII values of each character. If you can see, my range starts from 0 and it ends till 127. As you just saw, the value 97 corresponds to the character small letter a. The value 98 corresponds to the character small letter b, and so on. If you notice carefully, even the numeric numbers we write, for example 0, even this character has a specific ASCII value. So the character 0 has an ASCII value of 48. After the ASCII values of each characters are retrieved, they're converted into their binary forms, and then computer understands with the help of binary form the actual representation of a character. When the character 0 is written, it is first converted to the ASCII value and then converted to its corresponding binary form. So when the computer looks at the binary form, then the computer understands that we wrote a 0 here in between the quotation marks, and 0 is the resulting string. Now we will look at some built-in string functions. There are a number of string functions in the Python string library. To call a built-in string function, first I need to provide the string or the variable in which the string is stored. Then I need to provide a dot, and then I just need to simply write the function name. And if the function needs an argument in between the brackets, I provide it. If it is not required, then I do not provide it. So a very important thing you should know, and I will explain in the next slide, is that string functions do not change the string itself. Instead, they return a modified string. So what does this mean? We will now check it out. Also, a benefit of using these strings functions is that it saves us a lot of manual time. Out of all these built-in functions mentioned here, the first one is lower. So the lower function returns a copy string with all lowercase letters. In this example, in the first line, a variable line is created, and in the variable line, a string which is hello world is stored. In the next line, line.lower is written. This means the lower function is called on the string variable line. If you remember very closely from the previous slide, to call a function on a string variable, we first write the string variable or the string and then dot and then write the function name and then parenthesis. Also, please remember that strings are immutable, meaning as I've declared a string here, I cannot change the characters of this string. As soon as this lower function is called on the string variable line, this automatically returns a new string similar to hello world, but in this case all the characters will be of smaller letter. So the new string will then be stored in temp. Please remember, when we write line.lower, we are not actually changing or altering the characters of the original string variable line of string hello world. Instead, a new copy string is returned with all lowercase letters, and then that new string is stored in temp. In the third line, when we print the line variable, we see hello world is printed just like before. So this means that when invoking the lower function, this does not necessarily change my original string. And then when I print the temp variable, we see a string of hello world is printed. However, all of these characters are in lowercase forms. Similar to the lower function, there is also an upper function. However, upper function returns a copy string with all uppercase letters. So this is just a mistake. This will be upper. The third function we'll be seeing is the strip function. So this strip function returns a copy string with all white spaces removed before and after the letters. Meaning, as you can see, this string has some white spaces at the beginning and some white spaces at the end. So if I use the strip function on this string, white spaces at the beginning are no longer there. Also, the white spaces at the end are no longer there. Please notice the strip function ignores the white spaces in between the string. It only removes the white spaces at the beginning and at the end. Similar to this strip function, we have an else strip and an r strip. The else strip stands for left strip, which means it only strips white spaces at the left of the string. And similarly, the r strip, it only strips and removes the white spaces at the end of the string. In the fourth function we'll be seeing is the count function. And in this count function, a substring needs to be given as an argument, and this returns the total occurrence of the substring. So in the string Bangladesh, if I invoke the count function and in the argument, if I give in the character A, I will get in the total occurrences of character A in the whole string of Bangladesh. So as you can see, I have two A's here. This is the first A and this is the second A. Since there are two A's in this whole Bangladesh string, So I'm getting a return value of 2. In the fifth function, which is called starts with, we give a substring or a part of the string inside as an argument, and this function returns true if the string starts with the given substring. Let's look at an example. In this example, as you can see, I invoke the starts with method on the string hello, and as a function argument I pass in capital letter H and small letter e. Does this string actually start with capital letter H and small letter e? Yes, indeed it does. So a true is returned here. However, if I had written small letter h and small letter e instead of this capital letter H and small letter e, I would have gotten false here, because this hello string does not necessarily start with this substring. Similar to the starts with function, there is also an ends with function which returns true if the string ends with a given substring. However, if the string does not end with the given substring, we get a false value. In the find function, again we give a substring as an argument. This find function returns the index of the first occurrence of a substring. In this Bangladesh string, I am invoking the find function. So Bangladesh dot find and then apostrophe a. My machine will find the first occurrence of a in this string. So as you can see, if you remember string indexing, the first letter is 0, then it is 1, then it is 2, and so on. So find and then small letter a. As you can see, in the first index I have a small letter a. As the find function always returns the first occurrence of the substring, I am getting 1 in return, meaning I have a in the first position of the string Bangladesh. The last function we'll be looking at is the replace function. Here we will get two string arguments. In the first, we have to provide the old string and then comma, then a new substring. This replace function will replace every instance of old string with new string, meaning if I invoke the replace function on this string hello and my old string is. So before I end this slide, a very important point to note is that these are my return values. So in PyCharm, when you write this part starting from here to here, if you don't put in a print statement at the beginning, you won't be able to view this result. Similarly, for all these outputs, L and my new string is NT. What the computer will do is, every time it finds the occurrence of an L, it will replace that L by NT. So as you can see, HE, then instead of an L, I have an NT, and then again, instead of an L, I have an NT. Lastly, a 0 is printed. So these were some of the most common string functions we use in Python. I need to put print statements here at the beginning whenever I am invoking the functions. If you don't put in the print functions at the beginning, like we did in the previous examples, you won't be able to see the output. So apart from those functions, there are a lot more string functions present in Python. To view those functions, I use the dir function. So inside the dir function, if I pass on a string, any string, so this is a string, or if you give any kind of string or even an empty string, get to see all the string functions present in Python. So I don't have to memorize like what is present and what is not. So as you can see, we have the L strip we just saw, we have the R strip, and so on.